Hi guys, this is Soumyajit. Welcome to my channel Take Your Time. Today we are going to discuss Room Persistence Library with the help of view model and live data and MVVM architecture, and I will follow the complete implementation with the help of Kotlin as language. Uh, Now without further ado, let's get started. So the things we'll discuss today is obviously the database itself, view model, live data, and there is one more thing that I'll focus on is what are the architecture, what is the best possible architecture that you can follow to handle offline storing. Now, and also I'll discuss a little bit about what are the things that you can learn from here after this tutorial. So basically, just to start off, what is room persistence library? Now, many times in our applications, we have to give offline support to the users. So when the internet is not there, the users should see something to play it around in the application. So for that one, previously we used to use SQLite databases. And after that one, there are many databases that came up like GreenDAO and whatnot. So after that, now Google has launched Room database, which is none other than a wrapper on top of your SQLite database, which is previously we used to use. Now Room has a lot of support. It is added to the architecture components library also. So there's a lot of things that you can do easily with help of Room. So Room is basically built upon three basic pillars. One is entity, one is data access object DAO, and another is database itself. So what are these? Entity is none other than a data class or model class where you have to define how your table will look like. So for every table, you have to build separate entities or model classes. There you have to define all the attributes that you need inside that table. Room supports mainly primitive data types. Apart from that one, you can use different type of things to, if you really want to store different type of things, you can do a lot of tinkering. For that one, I will discuss that later on. What is DAO then? So DAO is none other than a interface. So inside that interface, you have to you have to define your methods with which you will access your entities. So let's say you need to update a certain value inside the table. So you need to define that method inside your DAO interface, and you have to annotate that interface with @DAO, and your entity class has to be annotated with @entity also. So what is database then? Database is an abstract class that has to be extended from room database and has to be annotated with @database, and it includes the list of entities associated with the database with that annotation, and it the database abstract class has to contain an abstract method that has zero arguments, and it returns the class that is annotated with @DAO. So let's say you have a DAO. So inside that database abstract class, you have to define an abstract method that returns the DAO. That's all. Now this is with this picture you can already get an idea what I have already told you guys. So the entities there, it is written, so get set value, so that does mean all the attributes has to be declared there, and you can you can make those changes onto that one only, and your entity is rather than the table itself. And the data access objects are used to make those tinkering with that entities. And your room database is the one which will give you the DAO itself. With that DAO instance, you can make those changes to the entities. Now, what is view model and live data? So basically, before starting that one, I'd like to focus on one problem. So let's say we have to make a every time there is an application opens up, we have to show some details to the user after an API call. So for that one, we have to make a asynchronous API call, and that may take some time depending on the network speed and coverage. So for that one, sometimes what happens is the user may have to wait a little bit depending on his internet state. Uh, Now let's say we are showing that one, but what happens is the user is changing his screen orientation. So the activity will again get recreated. So for that one again the API call will happen. for us to show the user the details, right? Now, every time this thing happens, it's we really can't go this way because the user has to wait a long time again. And what happens to the offline storing again? So these are the things we have to think of. Now, what we have is on save instance state where we can use bundles to store these things and again show it back. And if it is a complex thing, if it is a list of objects or maybe very big objects, not simple primitive data types, we have to use parse level or serializable to serialize those data and again show it back. Now, sometimes when the applications are keep on growing and there are complex things that you do, maybe that is not the best approach. So for that one, we have currently view model and live data. So what live data is not basically for that. So I'll come to it later on. So what view model is? View model is a class that is lifecycle aware and it survives the configuration changes and retains the data for you in when the screen orientation changes or something happens, so that you really don't have to make that API call again to show the data to the user. You will have it in the view model. So what happens is, in other words, this means that your view model will not be destroyed if its owner is destroyed for a configuration change. The new instance of that owner will just get reconnected with that existing view model. So basically that's it. So then what is live data? So live data, for me, live data is none other than a wrapper onto which I wrap my data sets. That's all. So what happens, let's say in your database you have certain things and you need to show it to the user. So if we can wrap the data that is coming out of the database with live data, what will happen is, anytime there is a change that is happening in the database onto that data set, your UI will automatically gets will get updated because the triggering will happen to the UI. So it generally it happens through observer pattern. So when the data held by the live data object changes, your UI automatically will get the updates in response. That's all. Now there is one more thing that I was talking about. So how we basically handle offline storing. So let's say we have a few data that is coming from the API itself. So we can go in two different manners. So I'll just give a brief about both of them so that we can get an understanding and according to the requirement and according to the situation that we are dealing with, we can go for the best approach. Now one thing we can do, we can always check for the internet if that is there or not. If the internet is there, we can call the API, get that data, change the UI and also put that data in the DB. And if the internet is not there, we can always look for the data if that data is there in the DB. If that is not there, we can show no data, or if that is there, we can change the UI from the DB. But only one problem is there. Every time before showing to the UI, we are checking whether the internet is there or not. If the internet is there, we are always going for the new data, or that is real time data, and again updating the UI and updating the DB itself. Now there is another approach that we generally say as single source of truth. So in that case, what we can do is, we can go for the internet. If the internet is there, we can go for the internet. We can get the real time data. We can put it in the DB. But to update the UI, we are always responsible for the DB. So the data that we are getting from the internet, we will not update our UI with that. We'll put that data in the DB, if they and from the DB itself we'll get that data to update the UI. The basic advantage of this one is, if the internet is not there, we will always have the data in the DB, so that we don't again need to think of the internet connection or not. So basically we can eliminate the first checking whether the internet is there or not. If the internet is there, get that data and update the UI, update the DB, and from there onwards, change the UI. And if the internet is not there, always your DB is having that data. So depending on the circumstances, we can think that what is best suited for us, and we can go with that architecture. Now, time for some coding. So let's get started with that one. So I already have the project lined up. So basically, in the project, whatever I have already discussed, that I will show here. So how I start with that one is, so in that project, what will happen is I will make an API call. I'll get some data from the API itself, and I'll put it in the DB, room DB obviously. And using the live data and view model, I'll update that in the UI. That's all. So for that one, first thing I prefer to do is I will build my model class. So this is my model class, and here I know that these are the things that I need, and this is, see, this is I have annotated with at the rate entity, and here I have defined that this is my table name. My table name is countries. So as soon as I annotate that with at the rate entity, Room database knows that this is a model class that has to be transformed into a table. Now then I will create my own DAO, which will give the connection between the table and the database, and for it will expose the methods for through which I can make those changes in the table itself. Now see, there are three methods that I have defined. One is your delete all, one is your insert all, and one is your get all. Basic things. And here I have for get all, there is not some annotation that has been provided by the room itself to get the data. So for that one, we can use the annotation called query, and we can pass on our own queries. So countries is none other than the table name that I have defined inside the country model. See, this is countries, and room will automatically take this name for you once you start typing. So, and insert I have so basically all these methods you have to pass on your arguments that you so for insert all countries I need and country list to insert in the DB. So for that one, I know that these are the things I will be passing on. So that is how I have written, I have passed this thing in the method itself. And this all get all countries, I know that this will be my return type, country model of list. That is why I have written this return type for this one. And delete all countries, I know I won't pass any arguments, and I am not expecting anything out of that one. So that is a void return type, nothing is the return type for that one. Now I have, for get all countries, I have wrapped this thing with live data. I'll come to it later on once I explain the complete database thing. And there is one more abstract class that I have defined. As I have already told you, the database class has to be abstract, and here it is annotated with @database, and it is extended from room database parent class itself. And here inside the @database, I have to declare all the entities that is there in that database, and the version number you have to give your version number of that database. And here is the abstract function which will return me the return type itself is the DAO that I have designed here. So that will give me the access to the DAO, and from there onwards I can make those method calls which has been defined inside the DAO to make the changes inside the country model or the table itself. Now there is, see, one thing in the insert I have defined at on conflict strategy. So there is a thing called conflict strategy. I have defined it is replace. So what happens is every time you define some table inside room, you have to give a primary key for that one. So basically what will happen is once the insertion will happen inside the room database, if it finds that the primary key violation is happening, or the same for me it is the name and it is a string type thing. So if there are two entries that is gonna get into room database with equal and same thing in the primary key attribute, it will it will not insert. So for that one, basically by default it will not insert. The config strategy is abort for that one by default. but for me I have defined the config strategy as replace. So the first one will get replaced by the second one, by the next one which is coming inside in the insertion. Now, coming back to it, why I have wrapped that one in the live data. So basically, what I will do inside the whole app is, this is my REST API interface, which I will use to call the API with retrofit, and I'll get this data, and I will put that data in the DB itself, and as soon as that is inserted in the DB, once I will wrap this one with live data using the view model. Once I will wrap this one with live data using the view model, I will get this update as soon as it is happened inside the database, and I will get this update in the UI. So for that one, I have wrapped this one in the live data. I have already discussed this thing. Now, so my app, in the app itself, I will make a custom application class, and inside that one, I'll define my database, and the database I have put inside companion object acts as the static thing for Java guys, I have told you. So this thing will give me the access so that I can use this database without instantiating this this class again. So I really don't need an object for this class to access this database wherever I require. So basically what I will do here is, my main activity will have a instance of my view model, and inside that view model I'll have a instance of my repository. In the repository I'll put all my business logic. So what I will do here, I have defined the base URL of the retrofit call. See, the first thing, the main activity repository. Here I have defined two functions, get countries and API call and put in DB. So this thing is responsible for to make the API call and to put that things in the database. So before putting that one, I am deleting all the previous countries so that my database is always having the real time things. And one more thing, guys, just to give a heads up, to make any operation with Room database, you have to make it happen with a different thread. In the main thread, you can't really make those changes. I mean, you can, but again for that one you have to add certain parameters in the Room database instantiation. By default you can't. So here I am making the API call and putting in the database. Now I have exposed another method inside this main activity repository to get those countries. So see, here I am accessing the database and the country DAO, and get all countries is getting called. Get all countries is where I have defined to select star from countries. So all the countries that is there in the DB I will get from get all countries. And these are the two methods I have defined here in the repository. Now in the view model, using my repository object, I have exposed two different methods, get all country list and get countries from API and store. So get countries from API and store is calling the API call and put in DB. So with this call, I'm making the API call and putting those new data in the DB. And with this call, I am getting the countries in the view model. Now, view model is having these two methods. Now in the activity, what I will do, I will have a object of my view model, and using the view model providers dot off dot get, I'll get my view model, and using that one I'll make those calls, and I'll put an observer for that one, so that any change that is happening in the case of get all country list, my updation of the UI will happen according to the new country list. So basically this view model providers dot off, what it does, it will be taking the activity or fragment as an argument inside that one, and this static method of will provide me a view model provider, and that view model provider I will use, and on top of that view model provider I will put my get method, and using that one I will ask the view model provider to provide me this particular view model. And once that is been done, that gets attached to my activity. So this main activity will gets attached to this view model. Now what I am doing, that if the internet is there, I am getting those countries from the API and storing that one. So I am calling this main activity view model dot get countries from API and store, which is calling my main activity repository API call and put in DB. And here I am making the API call and deleting the previous entries and again putting the new entries in the room database. And here what I have done is this view model get all country list. What is this get all country list? Is calling again main activity repository get countries, and it gives me back the live data of the get all countries from the DB itself. So see, this is I have defined. So query. So the changes that is happening in the database, as soon as that happens, I am observing that change, and using that country list I have passed the lambda here, and I am calling my UI updation with that one. Here I am updating a simple recycler view. So that's it, nothing fancy. So this is how we can use MVVM architecture to update the UI anytime any change happening, by observing any change that is happening in the database itself. So I'll run the application for you guys. I have made some log statement there, so that you can have an idea what is happening. So my app gets started. See, currently nothing is, I am getting nothing. Here you can see that the first call what is coming is the main activity one. Here we are not getting any array because at the first place there is no data. But this main activity repository, it is the call where we are getting the data from API, and as soon as we get the API, get the data from API in the main activity repository, you can see here the code is there to put the data in the database. And as soon as I put the data in the database data changes, and as I have wrapped it with live data and it is coming through the view model to the activity, you can see as soon as the data changes, it is affecting the UI in the main activity. And here is this, as I am observing this one, here is the main activity where I have put the log statement to see this particular data sets, this one. So, and I am just updating the UI here. So with this approach, you can put a live data in the data set that you are gonna observe through your room database, and using MVVM and view model, you can get those data in the UI to update the UI accordingly. So I guess this was that at the end of this tutorial. One more thing before calling it a day, I'd like you guys to understand that this is only a basic thing, basic model, and this complete code will be uploaded in the GitHub, and I will share you guys the link of that one. If you really want to tinker with this project, you can go ahead and do it. And the main part of that one, that there are so many things beyond what I have covered in this tutorial. So you can really go on from here, like you can even learn little bit things like different type of conflict strategies that you may come across in the room database according to the complexity that you want to resolve in your application. I have used here conflict strategy replace, but as I have already told, default is abort, and there are so many ignore and all those, so you can learn a little bit about that one. And one more thing, I have opted for destructive migration. So what it happens is, if I am changing my database version, what room will delete all the data that is previously that was previously there in the database, and I mean whole the complete data will be lost, and accordingly new data will be inserted. But if you really want your users as I mean once you upload your app to your production, and afterwards you really want your users not to lose their data, but again you have to change your database schema, then you can write your own migration logics there. So in that case, you can't really go ahead and do this fallback to destructive migration here. You can't really do it. So you can learn a little bit migration logics. And one more thing, I have previously mentioned that room only supports primitive data types, but again, if you really want to put like a list of custom objects and like that, so you can learn a little bit about type converter, which acts as a conversion wrapper, through which there will be a class where you will write your conversion logic, and room will take that as a converter and convert all the things that you want to put your put in your room database in a string type or something that you want it to be converted to. And one more thing, you can go ahead and start tinkering room with Dagger 2. So Dagger 2 is a dependency injection library with which you can inject your room database to the activities or the fragments where you need the instance of that one. I have already uploaded the Dagger 2 tutorial, so I will put the link of that one. If you don't know Dagger 2, you can go through that video as well. So, and in my next video, the complete this thing whatever I have mentioned today, I will be doing this thing with RxJava without live data and view model. So RxJava already works on an observer pattern, so we'll see how it goes ahead and does this thing. So that's it, guys. That's it for today. Hope you like this video, and if you have any doubt, you can put your comments or anything. I will try my best to resolve those things. And hope you like this video. So if you like that one, please subscribe to my channel. Take your time, there will be lot of good contents that will keep on coming. Okay, thank you so much, guys. See you.